Okay, so basically what we have is IO system with a backplane and a processor. This processor happens to be a PAC, and it does run a control program in it. And that control program is developed with, of course, PAC control, which of course you're familiar with. It's where you develop your strategy and you create your tags. In other words, this is a push button, and it's going to have a name associated with it. These are temperature probes. This is air temp 1, air temp 2, things like that. That's all configured using the tool PAC control. So I'm going to pull that up right now. And re-download. Okay, so now I'm looking at basically all of those points that I just mentioned. There's air temp 1 and air temp 2. So this is the PAC control development environment, of course. And I'm in debug, so I'm live online right now. So if I click here, I can see that indeed that the temperature is 72 degrees there. And again, we're just totally within our system here. So as I start to warm that up, we should see that value start. You see there the X value starting to go back up to 74, 75, and so on. Okay, so once the strategy is created, and typically the controls engineer is going to create charts, and the charts are going to do certain things, like this particular chart's going to calculate RPM and turn the turbine on and off and so on. And he does so, the control engineer does all this with the tags that were created from the local IO points. But there's also other kinds of variables that are created too. So for example, now I'm looking at numeric variables of various types that are all used within the control program to do various things. Okay, and then the other thing that the PAC controllers support is something called strings, of course. So you got string variables and you've got string tables. Here's a couple of string tables that I have right now. So again, if I look at the data live, I can double click on it, and you can see I have an array of floats in this case. And over here, I've got an array of strings. They look like numbers, but these are actually all strings. Right. Now I'm mentioning all this because I'm going to get to it in just a moment with some of the other tools that we have for developing applications on top of this system. So once the control engineer's job is done or whatever, and he's saved his program, all of this will now be exposed through JSON. And it'll be done so through a what we call a RESTful API. So I'm going to minimize this screen. There we go. And now I'm actually looking at the device, and it's called GroovePAC. It's an IP address. That's just the name I have on the local router.
Gotcha.
Now when I go here, I'm going to delete this and just go right back to the device itself. Hit enter. And now I can see that I'm indeed looking at, and this is the JSON object being returned, and I can see the controller type, the firmware version, the max on the thing, the uptime in seconds. All that's data just by going directly to the parent device type. Now, how do I know what to put in the URL, or what are called endpoints? Endpoints come from the API. The API is here, and in this particular case, we have it up on Swagger. Swagger is just a place to document and distribute and configure APIs. So this is the actual API over here in an editor, and this over here is just the same thing except prettied up so we can see. So for example, you can see there is my HTTP GET device, which I did on the other tab, and it returns the controller type, so on, everything that you just saw, including a small sample of what that schema looks like. So if I go to here, I can see that I'll get a HTTP 200 OK, meaning I got a valid OK, and then everything comes back in this little JSON object here.
Gotcha.
I also see the different kinds of requests I might get if I do something wrong.
Right.
So for every call that's available to this controller, I can see it all right in here. Here's one, for example, says device strategy IO digital outputs. So I can actually copy this and Control-C copy, come over here, and I'll go back to here and Control-V. I got 2 backslashes, I'll get rid of it. Now I can go back and pull back the endpoint for digital outputs, and there they are. So now if I look at this, it's the red LED on the nacelle, turbine motor control. Now let's go see that in the control program. I'll go back to here, pull up that, come down, and you can see that there's the red light on the nacelle, right? So literally what we've done is we've taken all of the control, basically the control library or the database in the controller, and we've exposed it all through this JSON API. And it's a RESTful API. Now there's some other tools to get started on it, like you want to set up username and password. You can configure it for HTTPS. We have some tools that allow you to do that. Don't need to really get into them here. It's a one-time kind of configuration. But the big thing that any developer will use is absolutely this particular document here, which describes all the endpoints, how to get to the data, how to write data as well. So we support, in this case, here's a put. So I can say, I can put device strategy, digital output, IO name, and state. So if I have an output on here, I'm not sure I have one that's that I can turn on or off.
Right, with this thing. Strategy.
Yeah, without strategy running. But I can write to an output just as well from the API. The other thing that the API supports is multiple users and keys. And what that means is that, in every case, when I first start this system up, I'm going to set up at the very, very top. I think it shows it in here. Yeah, you got to configure.
Hold on, please. I'm looking up this table.
It may not be in this particular document, but you have to. Oh, here it is. Key ID value pair for authentication. So in other words, we're also going to set up things for a key and password, so that you can have read-only access or read-write access. Cool. So what that means is, to your developer, you may not want them to control anything, but to be able to get data from it, you would set up a key and a password for just read-only access.
Nice.
Okay. So once all that's done, you can start building your applications. All your application really needs to know how to do is to consume JSON packets. Mm-hmm. Now the other thing that we're doing is we're adding something called the developer.opto22.com. So I'm going to go to the home page of this developer site, and you can see here I've got this pack REST API. And this is where I can get to that YAML file, which I just showed you. So that's just another way that we can get to it. And this is, same kind of thing, all the schema, all the calls, and everything. A YAML file is important because in many cases, a developer may have an opportunity to import a YAML file into their environment. And the reason they do that is because it kind of integrates into their environment, so they know how to find out what all the gets and puts are. It's just another way of providing an interface. So it allows me to take the API and then create libraries for various programming languages. So the RESTful API is really just a way of getting to the data and or writing to the system data in the controller. But some people like to write in PHP, or they like to write in Java or C. And so what Swagger does is it has some tools. I don't have them up right now, but they have some tools that allow you to basically take the API and create libraries for your chosen programming language. So if you're developing, say, in Node.js, which is JavaScript on the server, there's a thing that will create libraries to make accessing these API calls even easier. You don't have to do raw calls. You can build them into a library and pull the library into your development environment.
Nice.
So that's a real powerful part of Swagger. Okay. Now, on top of that, how else could you use it? Well, if you're developing an application from scratch and you're writing in one of those programs, I've shown you everything you need to know.
Yeah.
If you rather do some things that we're using other tools to build applications, we have a recommendation to use something called Node-RED. Okay, Node-RED basically is a graphical user interface that allows me to drop nodes onto a canvas, and underneath these nodes are various things that you can do, including straight JavaScript. So for example, here I'm just doing a quick JavaScript for pulling down a message payload. That's basically a JSON object. So that's one example, and that's kind of a higher end example, but there's a lot of simple examples as well. But what's important here is how we pull data from the pack into this environment. And it's using the REST API to do it. So if I double click on here, I can see I have a controller called Groove Pack. I can have several controllers in here, and it's an analog input, and all of my data types are supported. The ones I showed you in Pack Control are all listed here. So I select the one I want, and I select the tag name, AirTemp1, we saw that earlier, and then there's just a name for the node. So in this case, every 5 minutes, I'm going and getting the ambient temperature, I'm formatting it for AT&T's M2X IoT platform, and then I use this M2X node to push that data up to the cloud. So if you wanted to, just provide basically a proxy or an interface for grabbing data from the pack and moving it to various cloud applications, you can do that here. Cool. There's a lot of tools in here as well that allow you to, manage the messaging. This is mostly for debugging, and I can see the results of those, some of those calls right over here. So Node-RED works in conjunction with something called Node.js, which I mentioned briefly earlier. And Node.js is simply the ability to run JavaScript at a server level. So JavaScript has always been able to run in a browser. On any browser that you can get from anywhere, on any platform, all browsers have a JavaScript engine. In Google Chrome, which is the browser we're using here, that engine's called V8. Node.js takes that Chrome V8 engine and runs it on the server, and what it in fact means is you can now write server applications using JavaScript, and it's called Node.js. All Node-RED does is provide that graphical user interface to create JavaScript on the back end. It gets compiled to JavaScript and is executed on the server. So there's lots of examples here where I can read spot pricing, I can report by exception, I can build tweets, and I can do queries. For example, here's one that I mentioned earlier where I showed you in the pack, I showed you two tables, a float table and a string table. And it had a whole bunch of information in there relative to the weather. This is how I've done it. I'm using a simple node here called an HTTP request. If I open it up, you can see I'm just making a JSON API request via Weather Underground. If I open it up, you can see I'm just making a JSON API request via Weather Underground's RESTful API.
Gotcha.
And there's RESTful APIs for just about anything.
Yeah.
Thank you for coming.
So here it is. I'm pulling back a JSON object, and I am returning it as a parsed JSON object.
You're doing a great job.
And then I pull that in, and then on these two function blocks, they're just using regular JavaScript. And in this case, I'm simply grabbing the object, the various branches of that object, like here, current observation, observation time. Where did that come from? That came from the JSON object I pulled from Weather Underground. That looks just like this. Here I just made a browser call to the exact same endpoint. And the only real thing that's specific in here is, of course, my key and the weather station's ID number. So when I look at those two things, and if I hit refresh, it'll make another API call, and then I come back down to here and I say observation location dot full or dot city or dot whatever. That's the same thing as what I was doing here in Node-RED. I'm going current observation, observation time. So let's go down there. Current observation, observation time.
Right.
There it is. So I grab that here in Node-RED, and I simply put it in a variable called observation time. Then I do that to a whole bunch of data that I want that's all string data, and some of that string data I have to parse out into a float, or from a float into a string.
Gotcha. Okay.
And then I build the payload. The payload simply takes all those variables I varred, and that moves them into the string table in the pack. See right there? So it grabbed the API call, extracted the data, put it in a payload. The payload comes right down to here, and it says write string to weather data. So now here's something kind of cool. I'm going to clear my debug window, and by taking this tab in and out, I can turn the debug message payload for this on and off. I can deploy. This is the same thing as hitting run in the control strategy. And I can inject, instead of waiting 15 minutes, I can just do an inject on either one of these. Boom, there it goes, and there's my array.
Right.
All string array, JSON object gets written right down to the table in pack controller. Let's go look at it. And let's come down to string tables, string weather data. There it is. It's saying that the weather is 80 degrees outside right now. Let's see if it said the same thing in Node-RED. It sure did, right there.
Cool.
Okay, I'll turn that off. Now there's sometimes when I want to get data that's as a float, and the reason why is I'm going to actually show you the Groove screen where we're actually getting this data back into Groove. Here it is. In this case, all of this is our mobility product. You know a little bit about that already, about Groove.
Yep.
So we just built an application, that's Groove here. And by the way, Node-RED right now is running in this box along with the Groove application that I'm showing you now up on the screen. These are floats. For me to use this round gadget here, it needs to be a float.
Yeah, you can't use the string.
Can't use a string. Well, I could, but it's complicated. So I just want to get to a float. So I go back to my Node-RED, and you can see I'm extracting some data, and I'm making sure they're all floats. And then I put that in a payload, and it's all predicated with the F, meaning it's a float variable. And then I move that data into a float table. And that's that float table there, back down in the Groove pack. And so if I look at that data, I'm going to go ahead and debug that, do an inject. There's my float, just comma-separated variables, all float values. And I come over here to the pack, look at it, pull the float weather data, there it all is. Now once I have the float data, I'll go back to the Groove application, and I pull all the float data in. Now I'm trending all that data. So basically I'm pulling data from another weather station somewhere, doing the parsing, and then making it available, and now trending and storing that data in the pack. That's in essence what that thing does. There's tons of things you can do here. There's Twitter nodes. You know, if you want to write data to Twitter for whatever reason. This one's a big one here. This is a way where I have a variable I'm looking at, and if I press a variable within the controller, it's just a numeric variable called I have it NR because to me that means it's Node-RED. So from Node-RED I'm triggering a store procedure. So basically that means I have some button or something tied to that variable. If I press the button, I'm going to do this, or look at the value of that integer. If it's 0 to 5, and based on whatever number I put in that variable, I will write data to a database. This one here, for example, writes time series data. As you can see, if you're familiar with the stored procedure, it's simply executing that stored procedure called time series data. And when I do that, I don't have to end out anywhere. That calls that command. So what happens there? SQL goes and makes a call. Now, where does it make its call to? Again, in this particular case, I'm using, whoops, sorry about that. I'm using SQL Server. But in essence, the way this is how it's done. I'm using this DBO, and these are all stored procedures. In that one case, I'm using this one called DBO time series data. So I look at it, and this is in essence the code. But as you'll notice, or you may not notice, what it's actually doing is making a RESTful call directly to the pack. No Groove, no Node-RED or anything like that. All we said is go make the stored procedure call. The stored procedure call makes a direct connection to the pack, grabs the data, and stores it into a database. That database looks like this. Okay, so now if I execute that, I can see that there's the turbine and so on. So if I want to write that time series data, remember I said I had to write a value to that variable? That variable is here in Groove, and I'm going to squirt over there. I'm moving kind of fast, but there's my turbine. Right here are those 5 variables: temp, RPM, speed, yaw, or time series data. When I click that, you'll see my sprock. I'm calling sprock number 5. It ran. It sent the message up to SQL to go run the stored procedure. The stored procedure came down, grabbed the data directly from the pack via the RESTful interface, came back in here. I'll execute, and there's my new data series.
Cool. Yeah.
Okay. Now this would work, of course, with MySQL as well. Basically, all you need is a JSON deserializer. SQL Server will include one in version 2016, but this is actually an older version of SQL, and it doesn't have it, but there's lots of the developer who did this particular piece just downloaded a JSON deserializer from somewhere on the internet. So this notion of being able of Node-RED communicating to the pack, Groove communicating to the pack, and a database or any other external system all can now occur through this RESTful API.
Because it's a professional side, I guess. But
Now this is just using T-SQL. Well, not this. This is just the query for the data.
Right.
But all of this is done using T-SQL. So you know, it's relatively straightforward, and there's other methods for other databases. So if you're using MySQL or something else, then you'll use the tools to again go make an HTTP request, which is a JSON call or an API call that returns a JSON data, deserialize the JSON data, insert it wherever you need it to go.
Okay, cool.
So that's the soup to nuts.